dear champions, welcome back to day 67 of 99% in 99 days. So today we are going to discuss something very important, that is all the chemical reactions in all the chapters of chemistry in just one video. Many of you have requested like, ma'am, please come with some video where we can find all the reactions at one place so that it will be helpful for revising, so it will be helpful to just go through all the reactions at a quick moment. So this will be very helpful for all of you, and that is why we have come up with this video. Okay, so what you have to do, you have to sit with a notebook and a pen and write down all the reactions in one sheet of paper, and then you keep on revising that till your exams are there. Okay, so yes students, with this let us start the first today's what all things we are going to do. So first thing, as I told you, we will be discussing so many chemical reactions from different chapters. The most important, the most repeated I can say reactions will be discussed. Okay, so I have gone through even almost last 10 years of papers, 10 years of sample papers, and I have collected certain reactions which are repeated every year in one or the other set. Okay, so these are the reactions that you have to revise again and again before your exam. Okay, so that's what we will be discussing today first. Okay, now apart from that, there is something bonus for you. The second thing is color of the compounds. You know, in so many the 5 marker, 4 marker case based questions, or even your 2 marker, 3 marker, sometimes it is asked that a color changes from silver to grey, what is the compound? Okay, or some black color precipitate is formed, white color precipitate is formed, yellow color precipitate is formed, brown color gases are evolved, right? Blue changes to brown. So what is the change happening? So many questions based on the color has been asked. So to help you with this, what I have done, I have made a list of compounds whose colors have been asked repeatedly in the last 10 years of papers. Okay, so at that once you will be having all the compounds whose colors you can remember, and these compounds are asked even in the questions. Now second, this is done. Third, what we have? Third we have is, that is important common names. So many compounds are there whose direct chemical formula is not used, rather their common names are used. You might know, be like for example, question is asked, write the decomposition reaction of your for example limestone. Okay, suppose this is the question. You know the decomposition reaction of calcium carbonate, but you don't know what is the formula of limestone. Then will you be able to solve that question? No, right? So in this way what happens, we easily lose marks even if we have studied that particular concept. So to avoid this, I'll be giving you the list of all the compounds, their common names, which is asked in the exam. Okay, so that too after analyzing the last 5 to 10 years of papers. Okay, so moving forward, we have here the list of reactions. Okay, so here these are the these are the reactions from different chapters that you should be remembering. So first of all, I'll get a bit side. You can take a screenshot for this one. So just take a screenshot of this one, and then you can revise these topics, you can do the reactions, you can have a list, and whenever you're going to before exam, make sure that these topics you have covered at any cost. Okay, these are the most important reactions from all the 4 chapters. So in the first one, that is your chemical reactions and equations, you should be knowing combination reactions, decomposition reaction, displacement, double displacement, oxidation and reduction reactions. Okay, so you should be knowing their definitions and at least 1 or 2 examples. Now coming to decomposition reactions, you should be knowing about the 3 types of decomposition, that is your heat, light and electricity, right? So in that also so many questions can be formed, so everything about that you should be knowing. Now second category is your acids, bases and salts. I cannot tell you how important this chapter is. This chapter is full of reactions. You have reactions of acids with metals, acids with non-metals, metals, bases reactions are there, acid bases reactions are there, so many reactions are there, right? So but we have to focus on all the important reactions. So first one is your chlor-alkali process. Every year I have observed question from this. Example questions will be like, what is chlor-alkali process, why this name is given, that diagram is asked. Then even questions from what are the products formed, at anode what is formed, at cathode what is formed. All these type of questions are asked from this particular segment. Next, coming to the preparation of baking soda, bleaching powder and washing soda and plaster of Paris. These are also very important, especially I will tell you baking soda and plaster of Paris are very important, and uses also it is asked. Next, coming to neutralization reaction. So, this is the, I can say, the core reactions, the heart reactions of the whole chapter. If you have understood as neutralization reaction, then 80% of the reactions of this chapters are done. Okay. Next, coming to metal oxide plus acid. Okay, this is important. Zinc plus NaOH. This is also very important reaction. Then you have reactions with metal carbonates, bicarbonates and acid. Okay. So, these reactions are what can be asked again and again repeatedly in the exam. Okay. Now, we have metals and non-metals chapter. Okay, the third chapter. Here also so many reactions are there. The first thing you should be knowing what is roasting, what is calcination, their difference, their examples. Then you have reactions of metals with acid, metals plus water, zinc plus sodium hydroxide. Here also it comes. Then reactions of metal oxides, what is thermite reaction and what are its uses, why the metals are used, which metals are used for thermite reaction. So many questions are asked from here. Then electrolysis and electrolytic reduction, how the purification of metal takes place, which is taken as anode, which is taken as cathode, where deposition takes place, everything as the copper purification, everything is required here. Next, coming to carbon and its compounds, the most important reactions are esterification and saponification, and many a times these two reactions are asked together in the exam. Okay. Then you have addition reaction. In addition reaction there are so many names like hydrogenation reaction, conversion of fat to ghee, that question also is asked under this section. Next, oxidation reaction, dehydration reactions are again very important reactions. Okay. So, I hope you have taken a list. I am not telling you these are the only reactions present, but yes, these are the most important, most repeated, most expected reactions for your 2025 final board examination. So, these reactions, so definitely you have to go and like complete and then go for the exam. Okay. Fine. Next, moving towards the all important reactions will start. First one is your combination reactions. So, what is the definition you should be knowing? A reaction in which a single product is formed from two or more reactants is known as combination reaction. Very simple example. Now, here one example of combination reaction is calcium oxide plus H2O gives you calcium hydroxide. Okay. Now, here you should be knowing their common names. Calcium oxide is called as quicklime. Okay. Then when it reacts with what, it gives you calcium hydroxide, and this is called as what? Slaked lime. Okay. Or lime water. Yeah, these common names are very important. And what is more important here, this reaction is used for whitewashing. Okay. So, what happens when the walls are newly painted? Okay, they are painted with this calcium oxide and H2O liquid, or we can say calcium hydroxide. It is painted with calcium hydroxide during the whitewashing. Okay. After that, what happens? We observe that after 1 or 2 days or after some day, that whitewashed walls starts to shine. Okay. What is the reason of that shine? That is the reaction here is the reason of the shining. What happens? See, now calcium hydroxide reacts with the carbon dioxide present in the atmosphere. Okay, you have walls, right? Carbon dioxide is present in the atmosphere. So, what will happen? Calcium hydroxide, which is present on the wall, reacts with the atmospheric carbon dioxide to give you calcium carbonate and water. Okay, and this calcium carbonate is called as what? Limestone. Okay, which has a shiny white appearance. Now, the water formed here gets evaporated, and now what is there on the wall? On the wall we have calcium carbonate, which has a shiny appearance, and that is why the walls shine after the painting. So, these all questions can be asked from these two reactions. Okay. Example also it can be asked, and about this whitewashing story it can also be asked. Okay. Next, another reaction, that is test for carbon dioxide gas. See, this particular reaction is also used as a test for carbon dioxide gas. How? Suppose we have done any reaction, okay, when gas is evolved, bubbles come out, right. So these bubbles can be of any gas, it can be of hydrogen, it can be of nitrogen, it can be of carbon dioxide. So how to analyze which gas it is? So there is a very simple test for that. Whatever gas is evolved, you just have to pass it through calcium hydroxide solution, okay, through a delivery tube. This carbon dioxide which is produced in any reaction is allowed to pass through the calcium hydroxide solution. Now what happens, because this CaCO3 is formed, okay, that is a white precipitate. This I will show you example. See, suppose this is my reaction container, okay, where I have taken some reaction and carbon dioxide gas is evolved. Now here we have a delivery tube, okay, and this delivery tube is connected to something where we have calcium hydroxide, or I can say slaked lime, okay, or lime water. Now when this carbon dioxide gas which is coming out from this test tube reaches here, okay, this lime water which is there, it turns milky, okay, milky means it becomes whitish. Why it is becoming whitish? Because this calcium hydroxide which is present here reacts with the carbon dioxide and forms calcium carbonate, okay. So that is why it turns milky. So we can easily guess that, okay, the gas that was evolved must be carbon dioxide. Now there is one more question here. Wait, now here there is one more question, that what if we add excess of carbon dioxide? Now see, what is there? Now when you have done this experiment, in this reaction you have calcium carbonate and water, right. So now if you have calcium carbonate plus water, okay, in the reaction mixture, and then you added what? You added extra carbon dioxide to this one. So what you will get? You will get something called as calcium bicarbonate, calcium bicarbonate you will get, and this calcium bicarbonate is soluble in water, right. So this calcium carbonate is soluble. So what happens, whatever that white precipitate you got, that will dissolve after some time. Now why that happened? Because you have added excess of carbon dioxide, right. So that is how we can use the test of carbon dioxide gas, and this reaction can also be used for whitewashing. These all questions can be asked under this one particular reaction, okay. Now moving forward to decomposition reaction, a single reactant breaks down to a simpler compounds, that is called your decomposition reaction. Now decomposition reaction can be done in three categories. It can be by heat, it can be by electricity, it can be by light, right. So you can see these are the examples where you get decomposition by heat, okay, by providing heat, and that is why it is called as thermal decomposition reactions, okay. So what is the reaction? You see calcium carbonate, easily you can remember, it breaks to give you CaO plus CO2, okay. Next, if you have lead nitrate, this reaction is important, okay, please remember, many of you do mistake in this reaction. Lead nitrate will give you lead oxide plus NO2 plus O2. Here what you should remember, NO2 is a brown color gas, okay. So if a reaction is happening and we are getting some brown color gas from that, then which gas it is? It is your NO2 gas, right. Okay, so next, moving forward, we have one more reaction, again very important. One second. Okay, so just mention here that this is your brown color gas, okay. Fine. Now another example is FeSO4. But how do you get exactly FeSO4? See, FeSO4 is present like this generally, okay, and this is called as green vitriol. You know, copper sulfate is called as blue vitriol. Similarly, FeSO4 is called as green vitriol. Now what happens when you heat it? You get FeSO4 and then this water molecules separate out, right. This is very simple, all of you can know. Now if you further heat it, okay, if you further heat FeSO4, then what will you get? Fe2O3 plus SO2 plus SO3. This is very important, Fe2O3 plus SO2 and plus SO3, okay. Now what is something special about this SO2? It has a very pungent smell, Okay, you can easily find that bad smell and guess that the gas produced is SO2 gas. So see, we have different tests for different gases. See, hydrogen gas, how will you guess? By bringing a burning matchstick which burns with a pop sound, right? Carbon dioxide, just now we discussed, by passing it through calcium hydroxide you will get calcium carbonate. If you like give extra carbon dioxide, it will turn to calcium bicarbonate. Then for NO2 gas, it is brown in color, right? Next, for SO2 gas, it is having a pungent smell. Okay, so that is how you can find these gases. Next, so you can see these all are thermal decomposition reactions. So now we have, this is also a decomposition reaction, electrolytic decomposition, sorry, electrical decomposition, electrical decomposition, right? Okay, so here what is the question asked, and two types of questions are asked here. Okay, so first is, one second, just a minute. Yes, so here what are the things that is asked? Let us discuss the question. This reaction is very simple, I guess nobody has doubt in that. So first question that is asked is the ratio. Okay, whose ratio? Ratio of H2 and O2. Okay, so you can see by the balanced reaction 2H2 and O2. So what is the ratio of H2 to O2? It is 2:1. So always remember what is asked in the question, O2 to H2 or H2 to O2. So please do not mug up this answer. You can see, balance the reaction and remember which is 2, which is 1. Okay. Next question comes, which is produced at anode, which is produced at cathode. So you know here what is the charge, H plus is there and OH minus is there, right? H plus is positively charged, it will move towards cathode, right? And OH minus is negatively charged, so it will move towards anode. So H plus will get converted to H2, OH minus will get converted to O2. So at anode we have O2, at cathode we have H2. Okay. Next the question is asked that water, we know, right, is a distilled water is neutral solution, right? We do not have, it is a neutral solution. Then why do we add some H plus in that? Okay, whenever we do this electrolytic decomposition of water, we add some amount of H plus to it. That is because when you add this few drops of H2SO4, it increases the conduction, the number of ions increases, conduction will increase, reaction will take place faster. Okay, so these are the questions that can be asked from this particular reaction. Okay, so this is what electrolytic or electrical decomposition. Okay. Next we have photochemical decomposition. Photochemical decomposition. Okay. Now see, photochemical decomposition means by using light you are decomposing that particular substance. By using light means you represent by H nu, right? You must have studied in physics, H nu is represented. Now AgCl, if you decompose with light, it becomes Ag2Cl. Here a very important question has been asked many times, color changes from white to grey. AgCl is white in color, but a question asked is like this, some amount of white compound is kept in sunlight, and after that if we observe the color of the substance changes to grey. What has exactly happened here? You have to explain that. So what is there? The white color substance that you have taken is AgCl, right? When you have kept under sunlight, it has undergone photochemical decomposition, and now after undergoing photochemical decomposition, it forms Ag, which is having white, you can say grey or silvery appearance. So that is why the compound color changes. Now similar reaction we have with AgBr as well. Okay, and this AgBr has another use, it is used in your black and white photography. So if a question is asked what is one use of this one, you can write down this one. These are the questions that have been repeatedly asked from these reactions. Okay. Next, moving towards to displacement reaction, you know, one of the element replaces the another element, and the element which is replacing must be a element higher in the reactivity series. Like for example, if I have write like this, so sodium, potassium can displace all these elements, sodium can displace from calcium to platinum, magnesium can displace aluminium to zinc, aluminium can displace zinc to platinum, zinc can displace iron and below elements, right. So, that is the reactivity series, and everyone should remember this reactivity series. If you haven't remembered till now, then it is a big trouble. Please remember right now and complete it. Okay. So, I think I can okay. So, that is what is the reactivity series. You must remember it. Please do not forget to remember it. Okay. Now, what we have the reactions, very simple example. See, Fe plus copper sulphate. You see Fe is present above copper sulphate. So, Fe can displace copper. So, Fe will go here, copper will come out. Zinc plus copper sulphate, again you can see zinc is more reactive, right. Zinc is more reactive than copper sulphate, that means zinc can displace copper as well. So, you have this one, zinc has replaced this copper, zinc comes here, copper goes out, and we have this one. Next, Pb plus CuCl2, lead is Pb and you have CuCl2, lead is also more reactive than copper. So, lead can also displace copper and we will get PbCl2 plus C. Okay, these are the examples of displacement reaction. Now, moving forward, we have double displacement reactions. Double displacement reaction is when you have, like for example, if you have one second, yes, if you have AB plus CD, okay, then what will happen? A will replace C and C will replace A. Okay, so there is two replacements, that means CB, A has gone there, that is one replacement, C has come here. Okay, CB plus AD will form. This is your double displacement reaction. Now, if you see Na2SO4 and BaCl2, so what will happen? Na will replace Ba and Ba will replace Na. So, you will get NaCl and you will get BaSO4. That is a double displacement reaction. Similarly, if you see AgNO3 and NaCl, you have AgCl and you have NaNO3. The Ag will go there and Na will come here. You will get AgCl and NaNO3. Next, if you see lead nitrate and K and I. So, K will come here and Pb will come here. Okay. So, what will get? KNO3 plus PbI2. Okay. And something special about PbI2, it is a yellow precipitate. So, if question is asked, some yellow color precipitate is formed, you can easily think about lead iodide. Okay, fine. Next, we have oxidation reaction and reduction reaction and redox reaction. Okay, so first of all, what is oxidation? What is oxidation? You know, remember, oxidation is addition of oxygen, removal of hydrogen, and reduction is addition of hydrogen and removal of oxygen. This is there. Okay. Now, ma'am, tell me in the terms of electrons also. So, let me tell you that. How to remember? Just remember this one, oil rig. Okay, oil rig. Have you heard this word before? What does it stand? Oil rig. O stands for oxidation. So, oxidation is loss of electrons. Oxidation is loss of electrons. Rig, reduction is gain of electrons. Okay, gain of electrons. That is a very simple trick. You can remember oil rig. So, those students who have understood this one, comment down oil rig. Okay. Now, coming to reduction reaction. You have example CuO plus H2. So, okay, let me see this one. So, here what exactly is happening? Oxygen is added to copper, addition of oxygen. So, that is why it is an oxidation reaction. CuO plus H2. So, what is happening? Cu plus H2O. So, what is happening here? Oxygen is removed from copper oxide. So, that is removal of oxygen. So, that is why it is a reduction reaction. Now, if you see this one, ZnO plus C plus Zn2Cu. ZnO to Zn, what is happening? Oxygen is removed. So, that is reduction. Carbon to carbon monoxide, oxygen is added. So, it is oxidation. Now, in the same reaction, we have reduction and oxidation. So, that is why that is a redox reaction. Okay, or redox reaction. Now, let us see this one. This is most important. Many a times in many papers these questions have been asked and students get so much confused about this. So please understand this reaction properly. You have to observe MnO2 to MnCl2. What is happening? Oxygen is replaced with chlorine, or I can say oxygen is removed. That means what? Removal of oxygen is reduction, right? Now if you see, HCl is converted to, sorry, Cl2. One second. Sorry. Okay, just a minute. Yeah. So now HCl is converted to Cl2. So what you observe from here? HCl to Cl2. Hydrogen is removed. Removal of hydrogen is what? Removal of hydrogen is oxidation. So I can write here to here is oxidation, right? MnO to MnCl2 is reduction. HCl to Cl2 is oxidation. This is done. Now if you see, one more question is asked here, which is the reducing agent, which is the oxidizing agent. Here a very simple rule is followed. The compound which undergoes oxidation, okay, will behave as a reducing agent. The compound which undergoes reduction will behave as an oxidizing agent. So if you see here, MnO2 is undergoing what? Reduction, right? So MnO2 will behave as an oxidizing agent. Okay. Next, if you see HCl, okay, HCl to Cl2, HCl to Cl2, okay. Now HCl to Cl2, it is undergoing oxidation, so it will behave as a reducing agent. Clear? So that is how you should be knowing which is oxidizing agent and which is reducing agent. Clear? Now let us go to the next one, that is your chlor-alkali process. This is also a very important reaction. Many a times questions have been asked. So here you can see what happens. Brine solution is taken, right? Brine solution is what? Solution of NaCl with water. NaCl with water will give you NaOH plus Cl2 plus H2. So what are the ions produced here? We have Na plus, we have Cl minus, you have H plus, okay. Sorry, you have H plus and you have OH minus, right? So H plus will move towards cathode, okay, and it will give you what? H2. Cl minus will go towards the anode and it will give you Cl2. Now this Na and OH will combine to give you NaOH. So what are the products in this reaction? Cl2 and H2. Cl2 at anode, H2 at cathode, and then NaOH will be produced in the solution. Okay, and why the name is given like this, chlor-alkali process, based on the products, that is chlorine and alkali, NaOH. Okay, fine. Next, coming to baking soda, its preparation is important. So you should know NaCl reacts with H2O and CO2 in presence of ammonia to give you ammonium carbonate and NaHCO3. Okay, now when you bake anything, when NaHCO3 is there, when you heat it, okay, it undergoes decomposition reaction and you get Na2CO3, H2O and CO2, and this carbon dioxide which is formed is responsible for the fluffiness in your bakery items. Okay. Now there is one more important compound, plaster of Paris, you know, calcium sulphate dot 2H2O, that is your gypsum, right? When heated you get calcium sulphate plus half H2O, that is your hemihydrate, okay, and this is your plaster of Paris plus 1.5 H2O. Okay. Please note down these reactions, do not worry. If you want, if you put in the comment section, we will be giving you this PDF also. You can directly take a printout and revise them, otherwise you can note down. Okay. So now let us see the reactions of metals with water. Na plus water will give you NaOH plus H2. Okay. So now if you want to balance this one, just make it 2 NaOH, then we have 2 water and 2 NaOH, right? Then K plus H2 will also give you KOH plus H2. Okay, I think you can balance it similarly, right? We can get it 2K, 2K, then we have 4H and here we have 4H, 2 oxygen and 2 oxygen. Calcium and H2O will give you calcium hydroxide. Okay. Now here something important you should be knowing, that when these H2 is produced, okay, this H2 is like we get a fire in that, we can find fire, it catches fire. The H2 that is produced catches fire. Why? Because this reaction is so much exothermic in nature, so much amount of heat is produced in this reaction that whatever H2 gas is produced, that also burns with that heat. Okay, so that is why we can see fire. But in case of calcium hydroxide, we do not see that, okay, and rather we see that calcium particles are floating on the surface. What is the reason for that? Here also this question is asked, very important. This one floats. What is the reason? So here you should first know that this reaction is not intensive as compared to reactions of sodium and potassium, right? So there is a gradual evolvement of H2. The reaction is very less exothermic, okay, compared to these two. And whatever H2 gas is produced, okay, that it is like this, see. So H2 gas is producing here, and these gases go and stick to the calcium metals, okay, and that is why it is observed as if they are floating, okay. It happens with calcium as well as with magnesium, okay. Next, coming to reactions of metals with sodium hydroxide, very important reaction, and many of you do mistake in this product. Zn plus NaOH will give you Na2ZnO2 plus H2. This is called as your sodium zincate, okay, a well known oxide of sodium. Fine. Next, coming to thermite reaction, again very important. Here what is happening? Fe2O3 reacts with Al to give you Al2O3 plus Fe plus heat. So since heat is produced, this is an exothermic reaction. You can see Fe2O3 to Fe, what is happening? Oxygen is removed, so it is undergoing reduction. Al to Al2O3, oxygen is added, so it is undergoing oxidation, okay. Next, exothermic reaction is done. Then this is called as aluminothermy. This reaction is called as aluminothermy because aluminium is used in the thermite process. And what is the application of this reaction? It is used in joining railway tracks, okay. And what any other metal can show this reaction? Yes, manganese oxide also gives this reaction, Al2O3 plus manganese plus heat, okay. So for thermite reaction, which two elements are there? Fe2O3 and MnO2, okay. Next, we have roasting and calcination. So what is the difference? You should be knowing roasting and calcination. Roasting is for sulfide ores, calcination is for carbonates, right. Then roasting is in excess of oxygen, this is in limited amount of oxygen, right. These are the difference. Example, ZnS plus O2, zinc ZnO plus SO2, calcination zinc carbonate ZnO plus CO2, okay. Next, we have this reaction of cinnabar is very important. Many times it is asked in the question. First, HGS, mercury oxide, the ores of mercury are called as cinnabar, right. So when it is roasted with oxygen, you get HgO plus SO2. And then what happens once this HgO is produced? This is very low reactive metal, so they can be purified by simple heating. So when you heat, oxygen goes out and only pure Hg is remaining, or pure mercury is obtained. Next, coming to someone is amphoteric oxide. What is amphoteric oxide? Which reacts with both acid and base. Reacts with both acid and base, okay. This is called as your amphoteric oxide. Now the question is here that amphoteric oxides can react with HCl and can react with NaOH, okay, both acid and base. So if you are reacting Al2O3 with HCl, you will get AlCl3 plus H2O. Al2O3 with NaOH, you will get NaAlO2 plus H2O, okay. So this, so if question is asked, explain that or give an example of Al2, if give an example of amphoteric oxide with the reactions, then you must explain this one. Or a question is like, why Al2O3 is an amphoteric oxide, then also you have to explain with reactions. Okay, moving forward to the reactions of carbon and its compounds. Addition reaction, we all know addition reaction. What happens if you have a alkene group, okay, and it is reacting it with H2, and for example I will write here like this, okay, this is what? Ethene, and the species I can write alkene. H2 in presence of nickel catalyst, okay. So this will give you CH3 and CH3, okay, and this is your alkane, or we can call it as ethane. So now this reaction you should remember, and what is happening in this reaction, ethene gets converted to ethane or alkene gets converted to alkane. Now coming to these two reactions, that is esterification and saponification reaction. So in esterification reaction what happens, you should always remember that this is also very potential question, and most of the time these two questions are asked. Okay, so esterification, there is a reaction of alcohol, okay, plus a carboxylic acid in presence of H plus to give you an ester. Okay, so like for example, if I have CH3 CH2OH plus, if I take an acid like carboxylic acid, okay, that will give you what, loss of water molecule will take place, and we will get CH3 CH2O CO CH3, which is an ester. Clear? Okay. Now the opposite of this reaction is called as saponification reaction. What happens, you take an ester, okay, and you treat it in presence of NaOH, okay. Here you are taking acid, here you will take base, then you will get sodium salt, okay, of carboxylic acid plus sodium salt of carboxylic acid plus 1 alcohol. Okay, now let me give an example here. Suppose we will take this particular ester, okay, that is what we formed in the CH3 CH2 C double bond O O CH3, right, CH3 CH2, okay, sorry, I wrote the structure wrong, one second, yes, O C double bond O CH3. Now if this is undergoing NaOH, like your saponification reaction, then what will happen, this part will get converted to alcohol, and this part will get converted to your acid salt. Okay, so if I write like this, I will get CH3 CH2OH plus CH3CO O minus Na plus. Okay, fine. Next we have oxidation of alcohols. So oxidation of alcohols, what happens, alcohols get oxidized to form carboxylic acid. Okay, so we have like this CH3 CH2OH in presence of oxidation. Okay, so here we can use any oxidizing agent like KMnO4, okay, K2 Cr2O7, okay, so that will give you what, acid. So you will get CH3 C double bond O OH. Okay, so always remember how many number of carbons are there in the alcohol, same number of you will be getting acid. So suppose ethanol is there, you will get ethanoic acid. For example, if you take propanol, that is CH3 CH2 CH2OH, okay, and if you undergo oxidation, you will get 3 carbon, that is CH3 CH2 COOH, propanoic acid. Next we have dehydration reactions. Okay, so in dehydration reaction what happens, there is removal of water and we get a double bond. Okay, so for example, we have CH2H and CH2OH. Okay, so here H and OH will be removed in presence of what, dilute, eraser, in presence of concentrated H2SO4. Okay, then what will happen, H and OH will be removed as water, right. So I will get H2O as a byproduct, and what I am here, CH2 CH2. Now you see the balancing of the carbon must be satisfied. Now it has just 2 hydrogen and 1, so 3 bonds are there. So when there is a loss, this one, here one, double bond is formed. So what I can say, when alcohols, okay, undergoes dehydration reaction in presence of concentrated sulfuric acid, they give you ethene, right, clear. So these were the reactions. Now I'll go to something very important, that is test for acid bicarbonate test. Okay, so this is also a question that is very repeatedly asked. A question will not be asked directly. Questions like a student has two test tubes A and B. Okay, in one there is ethanol, in one there is ethanoic acid, but it is not level. What experiment the student can do to identify where ethanol is present and where ethanoic acid is present. This question is there in many of your sample papers as well and in your previous year questions as well. So what you have to do, wherever there is, you have to add this bicarbonate. Okay, carbonate or bicarbonate you have to add to both the containers. Okay, so let us understand this one. See, yes, one second. Yes, now you have two test tubes. Okay, one is A and another is B. In one of the test tube you have suppose ethanol, or I can say C2H5OH, okay, ethanol, and in another you have CH3. Okay, it is not labeled, right, so we cannot put like this, but we know that in one it has CH3 CH2OH, which is ethanol, and in another you have CH3 COOH, which is ethanoic acid, right. Now what happens, see, in both of them you have to add something. What you have to add? You have to add bicarbonates. Bicarbonates, for example, NaHCO3. To this also you add NaHCO3. Okay, you can either add bicarbonates or carbonates. What is carbonates? Na2CO3. Here also add Na2CO3. Now what happens? In one of them we will find effervescence. What is effervescence? That bubbles coming out, right? When you open the cokes, right, you find the gases coming out, that is called as effervescence. So when this effervescence comes in one of the tube, the one in which the effervescence comes, that suppose for example let us assume that here we have got so many effervescence, so many gases have come out, so that must be your ethanoic acid. Okay, and here if you after adding there is no change, then that will be your ethanol. Okay, so what is the reaction here? So CH3COOH, okay, it will react with both sodium carbonate and sodium bicarbonate, Na2CO3. If it reacts with Na2CO3, what will get? First we will get salt, that is CH3COONA. Okay, then in another you will get CO2, and then in another you will get H2O. Okay, now if you have this one NaHCO3, sodium bicarbonate, then you will get what? CH3COONA plus CO2 plus H2O. Okay, so that is what salt is produced, CO2 or H2O. So but that will happen only with acetic acid or ethanoic acid. If you take here ethanol, in this place if you take NaHCO3 or Na2CO3, then there will be no reaction, or I can write no change. So I can easily identify that A is what? On the basis of this experiment, A is ethanoic acid and B is ethanol. Clear? So this type of questions is asked. So that is all in the reactions. Then I told you that at the end I will be giving you some very important colors of the compounds which are repeatedly asked in your exam. So let us look at them first. So I have given in set these two, lead oxide and lead iodide are yellow in color. Okay, so I have kept them yellow, but if it is not visible as yellow, let me write it again. Okay, so whenever a question comes, yellow precipitate is formed, yellow solution is formed, so always remember it can be of lead. Okay, you can have, so these identifying type questions are asked, like they will be giving you a brown color metal was used, or some reactions happened and after that we got a yellow precipitate, something like that. So whenever yellow comes, you can think of the starting material must be something made up of lead. Okay, Next, coming to NO2. Okay, NO2 is your brown color gas. Okay, FeSO4 green color, green vitriol also, gray, FeSO4.7H2 if you write, that is green vitriol. Okay, next copper oxide. Okay, copper oxide is black in color. Here a very simple question is asked in many of the sample papers and previous year questions. Metal is taken, okay, which is widely used in electrical wirings and all. After some days that gets changed to black color. What is the reaction involved? So when it is told that it is widely used in your wires and all, you can easily guess it is copper. Then copper undergoes oxidation, right? In the atmosphere oxygen is present. So copper undergoes oxidation to form copper oxide, which is black in color. That is why the copper vessels you can find after some time becomes black in color, right? Because of the formation of copper oxide. Next we have these all: magnesium oxide, silver chloride, barium sulfate, calcium carbonate. These all are white in color. Okay, so calcium carbonate we have discussed in very detail, right? So when is calcium carbonate formed? If you pass calcium hydroxide and carbon dioxide, if you pass carbon dioxide gas through calcium hydroxide, you will get calcium carbonate, which is a milky appearance due to its white color. Okay. Next, blue color compounds are also widely used: copper chloride, copper sulfate and copper nitrate. So mostly these are the, what I'll say, except copper oxide and copper sulfide, most of the copper products are blue in color: copper chloride, sulfate and copper nitrate. Okay, fine, this is done. Now let us move towards the common names. Okay, so I told you in many of the time in questions the common names are used to confuse you. Okay, so you might be knowing the reactions and everything, but you cannot recall the common names correctly, then you will do mistakes, right? So let us do this first. So first is soda ash. So soda means definitely sodium will be there, and ash is for sodium carbonate. Okay. Next, caustic is for OH group. Soda caustic means, or caustic soda means NaOH. Similarly, potash is for K and caustic is for OH, KOH. Milk of magnesia. Magnesia you can easily guess it is magnesium. Milk of magnesia, magnesium hydroxide. Then I have here quicklime. Okay, so quicklime is calcium oxide. Slaked lime and lime water is calcium hydroxide, and limestone is calcium carbonate. Okay, so these are the compounds which common name is mostly used while giving questions. So you should not forget them. Please remember these important names. Okay. So yes students, that's all in this class. So this video will be very helpful. You can revise all the reactions, all the colors, all the common names in this one video. So please watch it out and note them and write down all the important reactions and revise them thoroughly before going to your exams. Okay, that's all, and see you soon in the next class. Do not forget to subscribe the channel.